Have you ever stopped to think about where your electricity actually comes from? For most of us, it's some giant, far-off power plant. But what if it came from your neighbor's roof? A massive shift is underway, folks. We're moving away from that old model to something way more local and honestly a lot more exciting.
So how are we going to get there? Well, in this explainer, we'll start by looking at our changing power grid. Then we'll dive into what are called peer-to-peer energy markets. After that, we hit the big problem, the matching puzzle. But don't worry, we'll introduce a smart matchmaker to solve it, see how it performed in a real-world test, and then wrap up with why the future of energy is, you guessed it, local. Okay, so first things first. The power grid we've relied on for, what, a century? It was brilliant for its time, but it just wasn't built for today's world. The rise of renewable energy has completely flipped the script. Yeah, think of the old grid as a simple one-way street. You had a couple of huge power plants at one end, and they just pushed electricity out to everyone. Boom, simple as that. But the new grid, oh, it's a bustling two-way network. With solar panels popping up on roofs everywhere, millions of us aren't just using power anymore, we're making it. And this introduces a brand new player in the energy game, the prosumer. It's exactly what it sounds like, a mix of producer and consumer. You're a prosumer if you're pulling electricity from the grid, but also pushing your own solar power right back into it. So now you have millions of these prosumers all over the place, buying and selling. How in the world do you manage that? Well, the answer is pretty cool. You let them trade directly with each other in local energy markets. It's called a local energy market, or LEM. You can think of it like a farmer's market or eBay, but for electricity in your own community. So if your solar panels are cranking out more power than you can just sell that extra juice directly to your neighbor down the block who needs to charge their electric car. And this is a total game changer. I mean, these local markets are incredibly efficient because the power is used right where it's made. That takes a ton of strain off the main grid, makes it way easier to use renewables, and for the first time, it gives us, the consumers, a real choice in who we trade with. Okay, but it can't be that easy, right? And you're correct. This brilliant idea has a really tricky problem hiding just beneath the surface. When you've got potentially thousands of people all trying to trade energy at once, how do you match them all up so that it's fair and efficient for everybody? Seriously, just think about it. In a single neighborhood, you might have one person who only wants the absolute lowest price. Their neighbor, though, only wants to sell power to the house right next door. And someone else has a very specific amount to sell. How do you make everyone happy? Now, the source material calls this the challenge of heterogeneous characteristics, which is really just a fancy way of saying everybody wants something different. Some people are all about the price. Others need to trade a very specific amount of energy, no more, no less. Some really care about their location, keeping the trade super local. And others are thinking bigger picture, wanting what's best for the community as a whole. It's a real puzzle. And this is where things get really, really cool. This is where our hero enters the story, a brand new advanced clustering algorithm. It's basically a piece of brilliant software designed specifically to solve this messy matching problem. The absolute best way to understand this is to picture it as a super intelligent matchmaker. You know, like a dating app, but instead of finding you a date, it's finding the perfect energy trading partner for you. And it can juggle all those different priorities we just talked about at the same time. So, how does the smart matchmaker actually do its thing? Well, it's like a four-step dance. First, everyone submits their bids, what they want to buy or sell, and their preferences. Second, the algorithm does some initial grouping, putting similar bids together. Step 3 is where the magic happens, the weighted matching. This is the smart part where it pairs up groups based on what the community cares about most. And finally, step 4, the trade happens. The algorithm's secret weapon is something called weighted linkage. This just means it has the amazing ability to give more importance or weight to certain preferences. So if the community decides that saving money is the top priority today, the market operator can just crank up the weight on price. If keeping energy local is more important, they can crank up the weight on location. It's completely flexible. And don't just take my word for how groundbreaking this is. The researchers themselves say, and I'm quoting here, this is the first of its kind where clusters are built with developed weights instead of the distance or values of the sets. That's the breakthrough. It's not just matching numbers. It's building matches around what people actually value. Okay, this all sounds incredible in theory, but the big question is, does it actually work in the real world? Well, to find out, researchers put this algorithm to the test using data from actual communities and Journey. They ran a bunch of simulations on 2 different setups. One was a pretty small community with just 25 prosumers. The other was much bigger and more complex, with 120 prosumers that included not just homes but also businesses and even industrial sites.
And they tested two main scenarios. Think of it like a face-off. In one corner, they told the algorithm, your number one job is to prioritize price, get the biggest savings possible. In the other corner, they said, forget price for a second, prioritize location. Make the trades as physically close as possible.
And the results showed this really fascinating trade-off. When the algorithm focused on price, guess what? The whole community saw bigger economic benefits. Everybody saved more money. But when it focused on location, it was wildly successful at making sure way more of the energy was traded between immediate neighbors. It proves the algorithm works and gives communities a real, powerful choice. So let's zoom out for a second. What's the big takeaway here? This isn't just some neat academic project. An innovation like this is an absolutely critical piece of the puzzle for building the energy grid we're all going to need in the future. I mean, the big picture is that this algorithm makes local energy markets not just a cool idea, but something that can be truly efficient and fair. It's going to help us use way more renewable energy. It gives us more control. It can actually make the main grid more stable. And yeah, it saves people money. It's a win-win-win. This entire explainer is based on a peer-reviewed paper from IEEE Access published in 2023. It's a perfect example of how cutting-edge research is solving some of our biggest energy challenges right now. All of this leaves us with one final, pretty powerful question to think about. With technology like this becoming a reality, we are getting closer and closer to a world of truly local energy. So, what if your neighborhood could actually power itself?